Welcome to AmeenAcademy.com. In engineering mechanics regarding types of levers, let us do some solving problems. Example, a crank lever ABC with tension spring is shown in figure. The lever weight is 0.25 Newton per mm. Determine the tension developed in the spring when a load of 120 Newton is applied at A. Here, the load is applied here. Due to that, uh, spring tension will created. Now, weight of lever is given 0.25 Newton per mm. Force applied on the force applied on the effort arm force applied effort arm, that is for P equal 120 Newton. Length of effort arm, that is, we keep A, which is equal 300 mm, and length of load arm, keep this is B, which is equal 150 mm. Weight of lever AB is from A to B, the length is 0.25 into 300, because 300 mm length, each mm length is 0.25 Newton. So let us get it this 0.25 multiplied 300 equals 75 Newton, and is acting on the 75 Newton and is acting in adding CG of arm AB. That is from A to B, from A that is 150 mm, from A it's act. Therefore we can see now, taking moments about, suppose you can write the W here, this W is acting here, which is equal 75 Newton. Therefore taking moment about the hinge at B, that means we are taking moment about this 120 Newton into AB length, that is therefore tension of the spring into, that is 150 mm, 150 mm, that is equal here. Next is 100 into 120 Newton into 120 Newton into 300 plus 75 Newton, because it's a self weight of AB, Newton into half of that 300 is 150. Therefore, we have plus 75 into 150 equal 11,250 T into 150. Therefore, T equal 3,600 plus 36,000, 11,250 divided by 150. Now 36,000 plus 11250 equal divided by 150 equal tension in spring is 315 Newton. We'll check one more time the calculation. 36 plus 11250 equal divided by 150 equal 315 Newton. Next, here we got the tension in the spring. Next problem. A compound lever shown in figure is required to lift a heavy load W. Find the value of W if an effort of 200 Newton is applied at A. This 200 Newton is applied at A. Now, this is a compound lever. Effort P. Effort P is given 200 Newton. 200 Newton. Then from the geometry of the lever, from the geometry of lever, here F1 and F2 are fulcrum. AF1 by BF1 equal 225 over 30. 225 over 30 to 225 over 30 equal 7.5. Now, and leverage of the lower lever CF2, the leverage the leverage of the lever of the lower lever CF2 equal, that is CF2 and DF2 equal 300 plus 30 over DF2 is by 300 by 30 equal 330 by 30 is 11. Total leverage of compound lever equal leverage of link 1 and leverage of the link 2. Leverage 1 into leverage 2. Leverage 1 is 7.5 into 11. 7.5 into 11 equal 82.5. Therefore, we know that total leverage in compound levers is equal W by P. Therefore, W is load lifted, effort applied equal 82.5. Now we need W equal 82.5 into P, the load is 200 Newton, which is equal 16,500 Newton, which is equal, you can say 16.5 kilonewton. We have done. Please subscribe our YouTube channel.